Hello, welcome to our final study guide before the Unit 3 exam. There are 8 problems and we're going to jump right in. Let's start with number 1A. It says sketch the graph. Now, whenever we want to sketch a graph, the very first thing that we do is find our x-intercepts. And we'll do that by setting the function equal to 0. So in this case, I'm going to set this function equal to 0. And then using the zero product property, I set each factor equal to 0. So that means that my solutions are going to be x equals 0 and x equals 2. These are my x-intercepts. So we're going to go ahead and plot those. So at x equals 0, I have an x-intercept, and at x equals 2. Now, if you've watched my previous videos, I have a little bit of a different way of teaching graphing. So we're going to now start putting pluses and minuses. What these pluses and minuses do is tell us where we're positive, which means above the axis, like these would all be plus, plus, plus. Or minus means negative, so that means we're below the axis, right? That's where our graph is positive or negative. So we're going to start putting pluses and minuses starting on the right side. So for this first interval way on the right, our graph is either above or below the axis, either positive or negative. And the way that we determine how to begin is it always matches the sign out in front. In this case, since there is nothing out in front, that just means it's positive. So it'll put a plus sign over here. Okay, so that was positive, so we started positive on the right. Now we have a decision to make. At x equals 2, our graph is either going to flip from being positive to negative, in which case we're crossing the axis, or it's going to just bounce off. It'll be positive and then it will stay positive. So we have to decide how our graph behaves at x equals 2. So go to where you got the x equals 2 root. Okay, look at the factor above it. Now we need to examine the exponent for this factor. In this case, there's no exponent. That means that it's a 1. So you need to be very comfortable with the fact that odd exponents means the sign will flip. That basically means your graph will cross the axis. If you have an even exponent or multiplicity, then your graph, you're going to keep the sign. Basically, your graph will bounce off the x-axis. In this case, we have an odd exponent. So for my next interval, I am going to flip the previous sign. So it was positive, now it's going to become negative. Okay. We have another decision now to make at x equals 0. So go to where you got x equals 0, examine the factor above it, and the exponent is even in this case. Well, even exponents means we're going to keep the sign. So I'm not keeping this original sign way out in the front. I'm talking about the most recent sign. So the most recent sign was negative, so as we move to the left, we're going to keep it now. Remember, even exponent. So this will also be negative. Now we just have to connect the dots, okay, and draw our graph. So we'll start on the right side. The graph should be positive or above the x-axis, and then hit the x-intercept. Now our graph is going to cross and go below the x-axis. This means, hey, the graph must be negative. So we're going to dip below, but then hit the x-intercept. And now at 0, I'm not going to cross over and become positive, but rather it's going to bounce off and stay negative, because that's what this sign is telling me to do. And there you have your function. This would be f of x. Let's do it one more time. Okay, so as before, you're going to, number 1, set the function equal to 0 and find your x-intercepts. So we get x equals 0 from that factor, x equals negative 3, and x equals positive 1, and we'll graph those. At 0, at negative 3, and at positive 1. Now notice how obvious and humongous I'm making these x-intercepts. These are like my guide later. It tells me where where to take my graph, okay, how to guide it through. So I want it to be, I don't want to skip over any of them, so I make them very big and obvious for myself. Okay. So now we're going to start labeling positives and negatives starting on the rightmost section. So remember, to the right, it must match the sign out in front. Since there's a negative out in front, our graph is starting negative, or below the x-axis. At x equals 1, so we'll go now to where x equals 1, look at the factor above it, and examine that factor's exponent, which is a 1. By the way, if you notice, looking a little bit ahead, if you look a little bit ahead, you'll notice that all of our exponents are negative. All of our exponents are invisible. That means that all of these factors have the exponent of 1. Well, if they're all 1, they're all odd, that means that at each of these points we're going to flip the sign, right? Odd means flip. So without doing too much thinking, I can automatically, as I bounce across this, as I move across this x-axis backwards, I can just flip, flip, flip. So if I'm negative to start, then I'm going to become positive. And then at x equals 0, my exponent is 1 again. So it's odd, that means flip. At x equals negative 3, my exponent is odd again. So that means flip again, I become positive. And now we simply need to draw the graph following these instructions. So I'm starting to the right side, negative. That means below the axis. So I'll maybe go like this. I have to hit the nearest x-intercept. And now I'm going to go above and hit. And I'm going to go below and hit. And go above again. And that would be our graph. All right, let's move to number 2. 2 says, determine if x minus 3 is a factor. And if it is a factor, then continue factoring it all the way, right? Factor completely. Well, if x minus 3 is a factor, so to be a factor means that you multiply evenly into something. If you multiply evenly, that means that if you do division, you should have no remainder, right? Because you go in evenly. So whenever you see this terminology, like determine if something is a factor, what should automatically go off in your mind is, basically, I'm checking if the remainder is 0. That's it. You're going to do division and make sure you get a remainder of 0. So I don't know about you, but anytime I'm given the option of doing long division or synthetic division, I always like to do synthetic division. It's just easier, way easier for me. So I'm basically going to do p of x, which is this whole thing, divided by x minus 3 to check if it's a factor. So for synthetic division, we're going to take our divisor, the thing we're dividing by, set it equal to 0, and that's the number that goes in our box. Now my coefficients are 1, -1, -17, and -15. Now we'll do the synthetic division. Bring down the 1. 1 times 3 is 3. -1 plus 3 is 2. 2 times 3 is 6. -17 plus 6 is -11. This isn't working out so well for us. So our remainder, which is that last number there, is not equal to 0. So therefore, no. Our answer is simply no. X minus 3 is not a factor because it clearly doesn't divide evenly. Since it's not a factor, we're done. We've answered the question. Okay, let's go to B. So still, we're checking if x minus 3 is a factor, and if it is, we're going to fully factor it all the way. So as before, 3 is the number that goes in the box, and our coefficients are 1, -7, 7, and 15. So let's bring down the 1. 1 times 3 is 3. -7 plus 3 is -4. -4 times 3 is -12. 7 minus 12 is -5. -5 times 3 is -15. And this looks like it's going to work out nicely because 15 minus 15 is 0. So our remainder equaled 0 in this case. So yes, right, x minus 3 is a factor. But that's not what the question asked. It didn't just say answer yes or no. It said if it's a factor, continue factoring it all the way. So if you are asked to continue factoring, then after synthetic division, you want to rewrite your large polynomial as a product of your divisor. That's the thing you're dividing by, in this case x minus 3. Rewrite as a product of the divisor and your answer. And when I say answer, I'm talking about the answer to the division problem. So let's write our answer really quick. Since we started with an x cubed, we have to drop the power by 1. So it's going to be 1x squared minus 4x minus 5. So we can rewrite p of x then as the product, which means the multiplication of x minus 3 and x squared minus 4x minus 5. Cool. So we've actually factored this once. But we're not done because we can continue factoring that trinomial on the right side. It's a quadratic. We can use magic x. We need two numbers that multiply to -5 but add to -4. Those numbers are -5 and 1. And so in our final step, we can rewrite p of x as x minus 3. Then we'll rewrite this guy as x minus 5 times x plus 1 based on our magic x. And this, my friends, is fully factored. We can do no more. Let's do our last part from problem number 2. So we're still checking, is x minus 3 a factor? If so, factor fully. So yet again, 3 is the number in the box. Our coefficients are 1, 6, 5, and -12. And I'm going to do this one quickly, so if you want, you can just pause the video. And in this case, there's no way that x minus 3 is a factor because our remainder was like 84 or something crazy. Our remainder was not equal to 0. So, answer, no. X minus 3 is not a factor. If asked to explain why, we would say the remainder is not equal to 0. Let's move on to number 3. Okay, number 3 gives us two functions, f and g. And part A asks us simply to find g of x plus f of x. So we're just going to do the substitution. G of x is 2x plus 3. And we're adding that to f of x, which is 2x cubed plus 5x squared minus 3x minus 18. Now, you could have put parentheses around these if you wanted to, but remember, if it's just addition and there's nothing to distribute in, then we don't actually need those parentheses, and they should come down just as soon as you put them up, basically. Okay, at this point, we just need to combine our like terms. So starting with the highest degree term, which is 2x cubed, has no like terms, just copy it down, followed by 5x squared. Next, we have 2x minus 3x, which gives me -1x. Or you could just write that as -x. And then we have plus 3 minus 18, which gives me -15. Now all of my like terms are combined, and this would be my final answer. Okay. Let's go to B now. B is down here. Okay. B says, do f of x divided by g of x. So I quickly rewrote already what f of x is and what g of x is. And again, as I mentioned before, when given the option of division, long division or synthetic, I'll always choose synthetic division. So to do synthetic, the number that goes into the box We get that number by setting our divisor equal to 0. So let's see what x equals. So x equals -3/2. So that's the number that goes into our box. Now our coefficients are 2, 5, -3, and -18. Since we have a fraction in our box here, we have to remember at the last step to divide everything in our answer except for the remainder by the denominator here. We have to divide everything by 2 in our last step. So let's not forget that. And also because we have a fraction in the box, we're going to do our multiplication very, very carefully over to the side. So I encourage you to show your work. So let's bring down the 2. Okay. Now 2 times -3/2 is -3. 5 minus 3 is 2. We just learned that 2 times -3/2 is -3. -3 minus 3 is -6. Now -6 times -3/2. I'm going to show a little more work this time. So we multiply straight across. That's +18 over 2, which is 9. And -18 plus 9 is -9. And as mentioned before, divide everything except the remainder by the denominator here. So we get, that becomes a 1, that becomes a 1, that becomes -3, that's a -9. So, in our last step, as always, we'll drop the power of what we started with. We started with a cubic function, so we'll end with an x squared. Okay, and that's our remainder. So let's rewrite this guy. -9 over the divisor, 2x plus 3. That's our answer. All right, let's move on to letter C. It says g of x minus f of x. So as before, we're going to substitute. G of x is really 2x plus 3 minus, now in this case, because I'm subtracting, I actually need to put parentheses around my second function to make sure that I'm going to distribute that negative, that I subtract the entire function. So unlike part A, where the parentheses didn't matter, whenever you have a minus, you need to, oh my god, you need to put parentheses. So let's fill in f of x now inside our parentheses. That's going to be 2x cubed plus 5x squared minus 3x minus 18. And now we're going to distribute that -1 that's really there. So if I distribute it out, that really means just flip all the signs. So let's rewrite this. 2x plus 3 minus 2x cubed minus 5x squared plus 3x plus 18. And now we just combine our like terms. So starting with our highest degree term, minus 2x cubed, has no like terms, just copy it down, minus 5x squared. Okay, now we have some like terms. 2x plus 3x gives me plus 5x, and then plus 3 plus 18 gives me plus 21. All of my like terms are combined, so this is my final answer. Okay, now we reach D. D says list all the possible rational roots for f of x. Now I want you to notice this problem doesn't, it just says list the possible rational roots. Please pay attention. It does not say find the rational roots. It does not say solve the equation. It doesn't even say factor it. It just wants us to list them out. So when we're listing possible rational roots, that's when we do the plus or minus, the factors of the constant term at the top, and then the factors of the leading coefficient at the bottom or in the denominator. That's it, just list them out and then do all those combinations. So when I say the factors of 18, I'm talking about the numbers. So factors would mean the numbers that multiply evenly into 18. So numbers that multiply evenly into 18 are 1, 2, 3. 3 times 6 give me 18. 2 and 9 give me 18, and then 1 and 18. That's for our numerator. For our denominator, the only numbers that multiply evenly to give me 2 are 1 and 2. And now we have to do every combination of each numerator with each denominator, just like this. Okay, that's how you visualize it. So we're going to start by focusing on the 1. So I like to underline it and say, okay, ignore the 2 for now, out of sight, out of mind. We're going to put every numerator over 1. So that's going to be plus or minus 1 over 1, 2 over 1, 3 over 1, 6, 9, 18. Okay. And now I've done each combination of the numerator with this denominator. So I'm going to cross it out and now focus on the 2. So now I need to talk about 1 over 2, 2 over 2, 3 over 2, 6 over 2, 9 over 2, and 18 over 2. So I just listed all of these combos. Well, now that we're done listing them all out, now we can simplify our fractions. So let's look. For example, 2 over 2 simplifies to 1. 6 over 2 simplifies to 3. And 18 over 2 simplifies to 9. And now we need to cross out the repeats. I don't want to list the same number twice. So I already have 1 written right here. So I'm going to cross this guy out. Similarly, I already have 3 here, so I don't need to repeat it. And I already have 9. So my final list of answers is plus or minus 1, 2, 3, 6, 9, 18, 1 half, 3 halves, and 9 halves. All the highlighted numbers. The positive and negative version of each of these. All right, let's go to number 4 now. It says factor the polynomial and identify the number of roots. So for A, it's a binomial, but it's also cubed. So see if you remember this from several weeks back. It's actually called a sum/difference of cubes. And it always looks like this. Okay, something cubed plus or minus something else cubed. The way it factors is it turns into a binomial followed by a trinomial. That means 2 terms and then 3 terms in the second parentheses. And our binomial is simply a and b. And our trinomial follows this pattern every time. A squared and then a times b followed by b squared. And then, if you remember, we fill in the signs in the very last step by using this little trick to remember. SOAP. That means that our first sign is always going to be the same as whichever we started with, positive or negative. So in this case, we have a minus sign, so our first sign is going to be the same, which would be negative. The next sign right here is the opposite of whatever you started with. And then this last sign is always positive. Okay? So keeping that in mind, this is actually a relatively simple problem. All you have to do to get started is identify your A and your B. So remember, our formula is based on the fact that it's A cubed plus or minus B cubed. But we're plugging in A and B. So we actually have to find out what is the cube root of x cubed. So the question you should be asking yourself is, what cubed will give me x cubed? This answer is pretty obvious. It's x. Right? X times itself 3 times. X times x times x. It's going to give me the x cubed that I seek. And over here, again, the question you're asking yourself is, what cubed, or what times itself 3 times, will give me 27. Well, In this case, the answer is 3. So my b term is going to be 3. Once we've identified our a and our b, we just plug them in to this little formula we have here. So we'll open our parentheses. In our first parentheses, we need a, which is x, followed by b, which is 3. Next, I need a squared, so that means x times itself, that's x squared, followed by a times b, which is 3x, followed by b squared, which is 3 times 3, which is 9. And in the very last step, we go in and we put our signs. So I started negative, right? This is a difference of cubes. So I need to keep the same sign, the opposite, and then always positive. And that's our fully factored version. This doesn't factor anymore. Okay, sums and difference of cubes just go to here and then you stop. So we've done part of the question. The other part of the question said, find the number of roots. So here's a little nifty thing to know, a little nifty tip. The number of roots usually equals the highest power in the polynomial, or the highest exponent. Another word for the highest power exponent is the degree of the polynomial. Well, in this case, our highest exponent for x is 3. So we have 3 roots. Pretty straightforward. Let's do b now. So again, we have a binomial that with a cube in the front. So we should recognize this immediately as a sum of cubes. So we're going to use that nifty formula one more time. So copy it down. When you see it on the test, I recommend copy down the formula immediately. Next, find your a. What cubed gives me x cubed? Again, that's x. Find your b. What cubed gives me 27? Again, that's 3. And then we just plug in. So in this case, we have a, b, and then a squared, and then ab, which is x times 3, that's 3x, and then b squared, which means 3 squared, that's 9. As before, we go in and do our signs in the last step. So I need the same, the opposite, again, I'm looking here, so the same sign goes first, the opposite of the plus sign goes next, and then our last one's always positive. And as we mentioned last time, this is fully factored. We're done. Okay. To answer the question about the number of roots again, we look at the highest degree, which is 3. We have 3 roots. Okay, let's go on to our last problem from this, our last letter from this problem. So this problem is different in 2 ways, right? We have a trinomial, first of all, 3 terms instead of just 2 terms. And it's a quadratic. Our highest degree is 2. So we know how to factor quadratics, especially quadratic trinomials. We use magic x. I need 2 numbers that multiply to 9 and add up to 6. Those will be 3 and 3. So we'll factor this as x plus 3 times x plus 3. And that's fully factored. We're done. Now to answer the number of roots question is a little bit trickier here. Because notice, if I were to list out my roots, right, by setting this equal to 0, solving for x, you get a repeat root, right? X equals negative 3 twice. Well, that's not 2 different roots, that's just 1 root. So in this question, because we had that repeat, our answer is just 1 root because it's repeating. So another way you could have written p of x, since it's x plus 3 times itself, well, you could have rewritten it as x plus 3 whole squared. So we just get the 1 root at x equals negative 3. So either way of factoring this is okay here, whether you condensed it as x squared or not, but the answer is just going to be 1 root. Okay, number 5, I love number 5. The only thing it wants is to know how many roots. As described before, the number of roots typically is just the highest power. So let's look for our highest power, please. For 5a, our degree is 2, so we have 2 roots. For 5b, our highest power is 4, so 4 roots. I love that problem. It takes like 5 seconds per. Let's go to number 6. Okay, so at 6, again, it just says list the possible rational roots. As before, it does not say solve, it does not say factor. Please don't do any extra work. It doesn't say find them, just list them out. So, doing plus or minus, the factors of the constant term at the top or in our numerator, the factors of our leading coefficient at the bottom or in our denominator. So let's think, what are the factors of 16? What are the numbers that go evenly into 16, starting from the bottom? Always start with 1. We also get 2. 4 times 4 is 16. 2 times 8 is 16. And then, of course, 16 itself goes into 16. At the bottom, the factors of 1 are just 1. So this one's pretty easy since we don't have like several numbers at the bottom. It's just the 1. This is going to be really quick. So doing every combination, our answers are plus or minus 1 over 1, 2 over 1, 4, 8, and 16. Next. We're asked to do the same thing with b here. So, list the possible rational roots. So plus or minus, and these guys are going to go on top, the factors of 9 on the top, and the factors of 9 also on the bottom. Interesting. Okay. Well, the factors of 9 are 1, 3, and 9. And the factors of 9 again are 1, 3, and 9. So remember, we have to do the combination of each of these with each denominator. So we'll start with 1 and then go from there. We'll start with this one. I like to underline what I'm working with at the moment. So we're going to have plus or minus 1 over 1, 3 over 1, and 9 over 1. And since we're done with this denominator, I just cross them out. Now we're going to focus on 3. So I need the combinations. I need 1 over 3, 3 over 3, and then 9 over 3. And now we're done with that denominator, so let's cross them out so as not to be distracted. And now the combinations of 1 over 9, 3 over 9, and 9 over 9. As we did last time, in this stage now, okay, so we used up all our denominators, so we're done. Now in this stage, we go through and simplify and cancel the repeats. So 3 over 3 gives me 1. Since I already have 1, I'm just going to cancel it out and not worry about it. 9 over 3 simplifies to 3. I've already got 3, so I'll just cancel it out and not worry about it. Similarly, 3 over 9 gives me 1/3, which I already have. And then 9 over 9 gives me 1, which again, I already have. So my final list of answers, excluding those repeats, are plus or minus 1, 3, 9, 1/3, and 1/9. The positive and negative version of each of those numbers. Wow, we're almost done. We're already on number 7. We only have 8 problems. This is going really well. All right, so number 7 says, find the volume of the rectangular prism given some information. So first of all, rectangular prisms look like this. Little something like that. And usually when we're finding the volume, we're given the length, we're given the width, and we're given the height. Okay, so our volume formula is typically length times width times height. But if you observe in this question, they're not giving us the length, the width, and the height. They're giving us the height, so that's cool. But then they're giving us the area of the base. So you need to observe that the area of the base, this guy right here, is actually nothing but length times width. It's these. So the volume formula could be length times width times height, but you could also interpret it as the area of the base times the height, since these are the same thing. So in this case, we're going to obviously use that second formula. So let's write down volume equals area of the base, which is x squared minus 3x plus 2 times the height, which is x plus 5. So I don't know about you, but whenever I do problems like this, where I have a trinomial times a binomial, it's easier for me to rewrite it with the binomial out in front. Again, do you, and I'm going to do this because it's easier for me. Because this way, I only have to distribute twice, right? 2 terms. Whereas in the previous way, you have to do the first term and the second term. Oh my God, that's a lot of spaghetti stuff. So if you're like me and you don't like excessive spaghetti straps, going all over the place, go ahead and just rewrite it. It doesn't matter. You can multiply things in any order. So I'm going to start by distributing this x. So I'll get x cubed minus 3x squared plus 2x. And now I'm going to distribute this plus 5. I'll get plus 5x squared minus 15x plus 10. Now that I'm done distributing, we'll just combine our like terms. So I'll rewrite this x cubed because it's got no like terms. And then minus 3x squared plus 5x squared is plus 2x squared. I've then got plus 2x minus 15x, which is minus 13x, followed by a plus 10. My terms are all combined, so I'm done. This is my polynomial for the volume. For B, we're asked to do the same thing, but in this problem, they give us the length, they give us the width, and they give us the height. So we're going to use our length times width times height formula and just plug them in. So my length is x minus 4 times my width is x plus 2 times, and my height is 3x. So a super common mistake that people make at this point when they have 3 terms being multiplied together is they just start at the beginning and they just distribute all across. And that's incorrect. You can't just mesh them all together like that. The way to do this problem is to choose 2 factors to FOIL out first. I like to deal with first, okay? So you might want to start with these 2 and FOIL them first, and then when you're done, deal with the 3x. Or you don't have to do it that way. You can start with the last 2 first if you want. Distribute those, and then deal with the x minus 4. It doesn't matter what you do as long as you just choose 2 and do them really carefully. So since it doesn't matter, I'm going to go ahead and do something. I'm going to go ahead and do the last 2. Why not? Okay, I'm going to FOIL that out first. So I'm going to copy down my x minus 4. Remember, deal with that later. I'm going to distribute this. So I'll get, don't forget to put your parentheses. X times 3x is 3x squared. And then plus 2 times 3x is plus 6x. Okay. Now that I've chosen these 2 to do first, and there are no like terms to combine, now I can go ahead and FOIL with the first binomial. So I'm going to start with x. I'll get 3x cubed plus 6x squared. And now I'll distribute the minus 4. That's minus 12x squared minus 24x. Now we can combine our like terms. So I get 3x cubed plus 6x squared minus 12x squared is minus 6x squared, followed by negative 24x. My like terms are all combined. So we're done. That's my volume polynomial. All right, last question. Last question. So this problem asks us to write an equation for the graph. So for this type of question, write an equation, it's important to realize that there is no single right answer, but there are wrong answers. So when you see write an equation, you should immediately think f of x equals. Okay, we're going to write an equation. Since this graph is giving me the x-intercepts, like just by looking at it, I can identify 3 x-intercepts. That's the first step that you want to do, is to write those down. And I don't just mean like in your head, think about it. I mean really, really write them down. So we have x-intercepts at x equals -3, at x equals 0, and at x equals 2. So step 1, we wrote our x-intercepts. From there, we can write our factors. So if we had x equals 3 as our x-intercept, let me rewrite this just a sec. Since we had x equals -3 as our intercept, that means the factor should have been x plus 3. Next, if we have x equals 0 as an x-intercept, that usually means that it came from just an x by itself, usually out in the front. So I went ahead and wrote x by itself out in the front. Right, because then this factor, if you set it equal to 0, would give you the x equals 0. This one would give you x equals -3. So keep in mind, whenever you have a 0, just put an x in the front. And then if I have an x equals 2, that means the factor must have been x minus 2. So that's our first step, is write the factors based on the x-intercepts that you wrote up here. Okay. Next step, once you have your factors, okay, that's step 1. Step 2, now you're going to put the appropriate exponents. So this is what you'll use to choose the right exponents. You're going to observe the behavior of the graph. So whether it crosses the x-axis or whether it just bounces off. That's what you're looking for. If the graph crosses at a point, you're going to use an odd exponent. If it bounces off, you're using an even exponent. So let's observe the behavior of our graph starting at x equals 0. Okay, so at x equals 0, it's crossing. It's changing from being above the axis to below the axis. So that means we need an odd exponent there. So we could put a 1. We could put a 3, a 5, a 7. It doesn't matter. Or I could not write anything at all, because if I don't put anything at all, that means automatically it's a 1, which is odd. So you know what? I'm not going to put anything at all because I feel like that's kind of cool. Okay, now let's move on. So now let's observe the behavior of the graph at x equals -3. So again, it's crossing. That means another odd exponent. You know what? Why don't we be fancy this time and put like a crazy number? It just has to be odd, right? Because it's crossing. So I put 15. Why not? Okay, you can put a 3 or a 5 or a 7 or nothing at all, because that would be a 1. Now let's observe the behavior of the graph at x equals 2. So again, it's crossing. Again, I need an odd exponent. I'm going to be a little more reasonable this time. Let's put a 3. So now we wrote our factors. We have our exponents. And in our very final step, you want to make sure that the sign out in front matches the way that your graph behaves in the rightmost interval. Remember, whether it's positive or negative out here should match the sign out in front. So in this case, so let's write this. Put correct sign in front. That's our very final step. So in this case, our graph is obviously in the rightmost interval. It's positive. It's above the axis. So that means that in here I need to have a plus sign. But actually, if it's positive out in front, we don't really need to write anything at all because it implies that it's positive. So I could just leave this as my final answer and it would be perfectly fine. Okay. Another answer that you could write, I just want to expose you to a few options, are I could put like 5x times x minus 2 times x plus 3. Why is that correct? Well, again, the number that I'm putting in front doesn't matter because this will still evaluate to x equals 0. I'll still get x equals 2. I'll still get x equals negative 3. So what I did is I switched these orders as well. And that's fine. You can multiply them in any order. It doesn't matter. And then the other thing I did is I just made all of my exponents invisible, which means they're all 1s, which is good because I just need them to be odd. So whether you did something like this here or like this, both perfectly fine, and we're good to go. Just remember these 3 steps when you're writing the functions. Okay, I hope that was helpful for you, and I wish you the best of luck on tomorrow's test.